Hello and welcome to day 11 of Advent of Code 2024. In this puzzle we have a number of stones, a list like this, and they will change by every blink. Now they follow a specific rule that we are going to take a look at. So each stone has a number engraved on it. If the number is 0, it will be replaced with number 1. If it's not that, we would take a look at the length of the number. If it's even, so for example 12, 95 or something like that, then we split the number in half and split the stone in two, where the left part takes the left digits and the right part would take the right digits. So for example, if the number is like 1000, we split it by half. The left part would take 10 and the right part would get 2 zeros, but since this is a number, the leading zeros will be removed. So this is a single zero. Okay? If none of these two, multiply the number by 2024. So if we take a look at an example here, if we have this initial one, after first blink, this is not 0, so it will not convert to 1, and it has the length of 3, so it won't split in two. The only rule that remains is multiplying by 2024. So this will be multiplied by 2024, get to this number. This is 17, the length is 2, is divisible by 2, so it would be 1 and 7. In the next one we have this is having the length of 6, so it's divisible by 2. The left part is this one, the right part is a single 0 because the leading zeros will be removed. Okay, then 1 will be multiplied by 2024, we'll get to this. The same goes for 7, go to this, and we would continue on. Now the thing that we want to do is to get the input and then do it 25 times. And as you can see, it grows very big. So let's go to the code and see how it's implemented. For the part 1 is pretty straightforward. We just get the input, split it by space and map it to number, because we have just one line of input like this, so you don't need to split it by new lines. Then we need to run it like 25 times because it's asked to do it 25 times. Here we would have a new generation of stones, and every time we run the for loop we would create a new generation of stones and replace the stones with that. We won't do it in place because this is going to be very big, and splitting them into half in place would affect the whole array and it would take a long time. So here for each of the stones we'll just take a look. If a stone is 0, we need to provide a 1 into the new set of stones. If the stones is divisible by 2, if that stone, the length of it is divisible by 2, then we need to cut it in half. So we may convert it to string, so we can cut it in half. So left would take the left part, right would take the right part, and we push both of these into the array. Now we could do something like this as well. Would that make any difference? And in the end, if none of these two rules apply, we just multiply by 2024 and push it into the new stones. And when this whole process for the current stones is done, we just put the new stones generated into the stones, and then we will continue for 25 times. Now for part 2, this should be run like 75 times. So obviously it doesn't work to go here in the part 1 and say this is 75. It would take a long time. So the thing that I thought about is that if we take a look at this puzzle, we can see that for example 2 is repeated a bunch of times here. So instead of just looping through this and every time calculating the value for 2, in this case 4 times, we would keep track of both the number and the repeated times. So we would have a map saying that 2 is repeated 4 times. For example, 6 is repeated like 2 times and so forth. And when I get to 6, I would do the calculation and the new generation would be updated based on the number of times this value has been repeated. So if I get to, for example, 0 and there are like 2 zeros, in the new generation there will be 2 ones instead, because every 0 will be converted to 1. And if I, for example, if I get to like 80 and there are like 10 of them, I would split it in half and provide 10 8s and 10 zeros for the next generation. Okay, I hope this makes sense. So let's go and see the code. So for part 2, the first part is changed a little bit because as I said, we need to keep track of both the value and the count of it. So this is done here. We split it by this and we reduce it to a single object. We provide an empty object in the beginning and we set the count of each value to 1, because basically looking at this, all of these values have repeated only once. Then we have the stones as a map. Do the for loop for 70 times. This time our new stones is another object, and then we take a look at the stone and its count in the entries of these stones. So each time I get the stone and its count. And to make things faster, I would convert this stone to a number, because the objects, the key of the objects in JavaScript is always string, so we need to convert it back to number. Then again, the same rules applies. If number is 0, the new stones with the key of 1 is whatever it was before. So for some reason, if it was changed to 1 by, for example, dividing, then we keep track of those values and we add count to it. And if nothing has happened beforehand, we just say, okay, it was 0, we add count to it. Then the else is just the same. We divide by 2, get the midpoint, and then the left part is this value, just like part 1. No difference here. And the right is this value. And obviously we need to add this value to the previous value of the new stones. And similarly for the last part, we get the number multiplied by 2024 and we check that. If it's not in the list of the new stones, we add 0 to the count, and if it's in the list, we add that value to the count. So for example, if sometime we get to number 10 and we divide it, we would get to 1 and 0. So the map would contain a 1 and a 0. And then if we get to a number 0 and we get to here, we can see that the number of ones is already 1 because we have divided 10. So we need to add 1 to the count of the numbers of zeros that we have. Okay, and in the end we would just have a object with all the stones and their counts. So we get the values of stores because we need the counts, and we just add them all up and we get to the result. So I think the point of this puzzle was just using some kind of a map so that we don't repeat ourselves every time, and we finally can get to the final answer very fast. So I hope you have enjoyed the video. If that's the case, don't forget to subscribe to the channel and see you in the next video.